Hi, I've already showed you how to set up the initial printing a Mancala board application. This one is to show you how to add moves to your Mancala board. The one thing I have not done is anytime you make a modification, like this one was originally written in September, and then I always put in a modified line just to indicate and just put in today's date or approximate date is the 10 October 2020. And the purpose of this is adding the moves capability to the game. So in other words, I'm just adding it so I can do moves. And again, everything, all the includes are the same. Now, the prototypes that I have, the reason why I have prototypes is in C++, all methods or functions have to be defined before they are used. I can go ahead and define them later, but this makes it so much easier to write code. And when I start breaking out code into separate modules, then you can have something called header files that include the prototypes. And then I have these prototypes here. Which one is a check empty side? One of the rules for Mancala is if one side is empty, then all the stones on the other side go into the opponent's Mancala. So I just have a separate routine for that. It's easier to go ahead and have separate routines instead of trying to build everything into too large of a routine. The second one I have is then a player move, and I send in an integer, and notice that the ampersand is here. This means that I'm going to send in the player, but I'm going to send it by reference, which means I'm going to have a pointer to the player where the player value is stored, so I can modify it in the routine or method or function. It has so many different ways of calling it. Then on this is the ampersand means passed by reference. Most ones like this one here for solid line is passed by value. So in other words, the routine just takes the value, puts it into its own local variable, and does not modify the calling routine's copy of that variable. In this case, then I am going to modify it and pass back the next player's turn. So that makes my main loop a lot easier to do, so I don't have to check to see whose turn it is. And I can do all that calculation in the player move routine. Again, I use camel case so that all variables start with the lowercase letter, but any additional words always start with the capital letter. The solid line and the other thing is on some systems, which is really nice, is if you notice, then if I hover over the routine, then it tells me what the comments say so I can make sure that I fill in the proper information. And then this is true here also. Then the next change I made from the last time is I have the print 2, print 1 line. And then if you notice now, I have print board. And print board is the old main program. So then if I want to, I can say I can modify this, and I'll go ahead and modify it a little bit later so I don't take quite so much time, because I need to have then the definition of what is expected. In fact, I'll just go ahead here, and then I will go ahead and put in this comment. And go ahead then and say input none, output none, and purpose is print the board. And then I have the proper header for this. Then this again is the old main. You'll recognize this as printing out player 2's side, then the main middle line, then the player 1 line. Then I have a main program. And notice, because everything is all defined in functions, there are only basically 3 lines. One is the int, setting up the player. And notice then, as long as player is not equal to 0, this is why I do a call. And notice on the call to player moves, then I can just pass in player. I don't have to reference it in any particular way. And this gives me a actual reference to the variable player, so I can modify it in the calling routine. And then I just return 0 as a follow-up, because it says it's going to return int. That's something you have to be very careful with. Now, since I am returning player in this, then I do not have to go ahead and have any return here. And then I'm just going to have here, since I don't have a purpose, now it will only do 1 player's moves at a time. And so in this case, then I have it, to make it a little bit simpler, I have a low pit, and I just have the low Mancala number, then the 0 for the start of player 1's pit, and then 7 is the start of the player 2's pit, and 13 is the second player's Mancala. 5 is the end of the the end of the first player's row of pits, and 12 is the last pit of the second player. This way, then I can use the same routine more than once and just use the index of the player to define what is the low and high ends. System CLS clears the screen, and it's a nice way of doing it, so I have a nice clean board each time through. Then I go ahead and print board, and whatever's in the board at this time will be printed, because we're using a global variable array called board to modify the numbers. Then, if you notice, it is now player, and then I print out which player it is, 1 or 2. It's turn, choose between pits, and then notice I have here, if player equals 1, then it's 0 through 5. Otherwise, it'll be 12 through 7. I think I'll go ahead and maybe change that to 7 through 12. So now I'm going to loop, and then I'm going to then check to make sure that the pits are allowable. And if they're out of range, then I'm just going to loop back through here. So this choice is going to be done as many times until somebody gets a pit that is in the proper range. The one thing I have not done here is to check to see if a slot has a 0 or has 0 stones in it, if a pit has 0 stones in it. And if it does, then the person just loses their turn. So that's something that the user has to be aware of. And if you want to, you can add that, but I don't have it. Now, the one thing that happens is if somebody types in a letter instead of a number, then it used to be that the system would error out, have a system error. And so I could just put a try around the read of an integer. But now that doesn't work. So I have now a read of a string, and then around the pit, then this will fail if I type in a letter or letters. Then I have pit num equals, and then I do a string to integer conversion and put in the string. And this will go ahead and allow me to do the conversion and just make sure I have a proper number and that it is put into an integer. If this doesn't work, then what it does is I say catch exception, then please type in a number. And notice I set pit num back to -1, which will not fall, or which will fall into these categories because it'd be less than the low pit num. Consequently, it will loop back and cause the person to try to type in an integer with the error message, please type a number. Then we go here where we can start playing, and I say stones equals board pit num, so I'm grabbing all the stones. And then I go ahead and set the where I grab the stones to 0. And then if it is 0 to begin with, it's not going to go through this loop. That's why I'm using a while here instead of a do while, because I want to check to see if stones is already 0. And if it is, then I won't do any of these commands. Otherwise, I increment pit num by 1. And if then it's greater than 13, I set pit num back to 0. The rules of the game is you can go ahead and put in a circular direction. You can put in all the pits until you run out of pits, and you put in pits into your own Mancala, but you don't put it into the opponent's. So in this case, 13 is for player 2, so I don't want to do it, so I just hit continue, which will just continue on with the while loop. And likewise, 2 does not put it into pit 6, so I continue. Otherwise, then I increment that particular pit by 1, and I decrement stones by 1 so that I can eventually get down to 0 stones in my hand. And this will take care of putting in all the stones in. We'll take care of not putting it into the opponent's Mancala. And then check for last stone in each player's Mancala. And then the nice thing is if player 1's last stone was put in pit 6, then I'm saying go again, and I could combine these two ors, but I have them in separate statements. So then else if it's already checked that and it's happened, then I can check this 2, and again, is it checks the player first. If it's player 1, it didn't fit into this. Then it goes to player 2. It's not player 2, so it skips this completely. On an AND, it only does the first one. If that's false, then it doesn't need to do the second one. If this is true, it'll do the second one. And then we have else player equals 1. Then notice then these two will not change what they won't change what player is being played right now. So this allows the player to do a go again, which takes care of the last stone falling in the Mancala. Otherwise, then I will swap players. So in other words, if player is 1, then as player becomes 2, and if player is 2, then player becomes 1. So it swaps back and forth. And here's where I check the empty side, which I will explain as we go down to the next routine. And then if it is empty side, let's see, is that correct logic? Okay, yep. So then should probably have an else if here. Because I don't want to have it try to go ahead and do empty side. So I'm going through and clearing out all the stones on the opposite side, adding them in. And then if you notice, I am setting each of the pits to 0 so that it will appear empty also. And likewise, if empty side equals 2, then I will go ahead and add all the pits to player 1's Mancala. Now, it's real easy is if you decide there's two different rules. The way I play it is that if you empty your side, the opponent gets all the stones on their side and puts them in their own Mancala. Some people say that whoever empties first gets all the opponent's stones. All you'd have to do is change the 6 and the 13 if that's the way you want to play it. But in this case, then I'm saying if you empty first, then the opponent gets all their own stones. And then if empty side is greater than 0, in other words, 1 or 2, then I'll go ahead and print out a final board. And in which case, then if you notice going back up to this, and then let's see. Okay, yeah. Then otherwise, I'm going to return. Let's see if empty board equals 0, then I'm setting player equal to 0. And then if you remember from the top side, then on the main routine, I'm just looping until player equals 0. And this is the one thing that will trigger it to 0 because you've just emptied both sides. There's nothing to play. Then the check empty, notice hovering over it, in my case, will pop up a dialog box with the information about the call. And then this is setting up, because it's integer, I usually set up a ret val equals 0 to begin with. Then I'm setting up pit num, and I'm just going to go through pit num for 0 to 5. And again, I could do something like I did in the last one. So this is all set up properly. I mean, we can make it redundant, but this is two separate ones. And so then I check for each one. And then I've done if, and then in this case, I'm doing an if, checking for what the pit num is. And if the pit num is 6, then it's player 1 whose side is empty. And if it's 13, then player 2's side is empty. So those are the changes I made. And again, the one thing that's new I introduced here is the try catch. If you notice, you have to have exception E here. And it just is an error message, and then sets pit num to something that will cause me to reloop and ask again. If there are any questions, please ask, and we will end the recording now. Thank you.